Welcome back to ECE TechNest. In this lecture, we will be discussing about Module 2 of VLSI Design and Testing, that is MOS transistor theory. This module I'll cover in 3 different videos and I'll try to cover all the concept that is in this module. So the first concept is Introduction to MOS transistor. So first, coming to the definition of MOS transistor, it is a majority carrier device, and when current is applied in the channel between the source and drain terminal and is also modulated by a voltage applied at the gate terminal, it is called a MOS transistor device. And MOS transistor is further divided into two types, NMOS transistor and PMOS transistor. In NMOS transistor, majority carriers are electrons, whereas in PMOS transistor, majority carriers are holes. And in NMOS transistor, it is the positive gate voltage that increases the electron concentration, whereas in PMOS, it is the negative gate voltage that enhances conduction. Next, you have to write about the for gate voltages below the threshold voltage, that is VGS is less than VT, the channel is in cutoff region and is leading to very low drain to source current. I have already discussed the drain current equation and derivation. You can look into that video for more details. Next is PMOS transistor. The operation is analogous to NMOS, which means it is complementary or opposite of each other. And NMOS and PMOS has opposite voltage polarities. So the next concept is based on the threshold voltage. So what is threshold voltage? Threshold voltage is the voltage at which a MOSFET begins to conduct. So it is the minimum voltage at which a MOSFET will begin to conduct, and the source to drain voltage depends on the VGS also. As we have seen the equation of IDS, it also has the VGS, that is the gate to source voltage. Next is enhancement versus depletion mode. There are two modes of operation based on the conduction behavior. So first one is enhancement mode. In enhancement mode, the transistor is normally off and requires a gate voltage to conduct, whereas in depletion mode the transistor is normally on and also conducts even at zero gate voltage. Next one is difference between NMOS and PMOS transistor. In NMOS and PMOS transistor, they are duals of each other, also called as complementary of each other. So the threshold voltages at the NMOS and PMOS is represented like this. In the N-channel enhancement mode MOSFET, the graph of VGS versus ID is a curve, and this is the VTN, that is the threshold voltage of N-channel MOSFET. And in depletion region, the N-channel MOSFET will have a negative voltage, that's why the curve is from negative to positive, and therefore the graph is a curve along with the negative axis. Next is the PMOS or the P-channel enhancement MOSFET, and in P-channel enhancement MOSFET it is the negative or the downward curve. Similar to that, the P-channel depletion MOSFET has positive voltage here. That's why the curve starts from positive and moves towards negative. Next is the CMOS technology. Both NMOS and PMOS transistor together combine to form the CMOS circuit, and this we have discussed in module 1 also. The representation of NAND gate and NOR gate using CMOS circuit, as CMOS is a combination of both NMOS and PMOS. Next is NMOS enhancement transistor. So NMOS enhancement transistor is a voltage controlled device and it's used in digital and analog circuits. And in bipolar junction, we see it is the current control device, whereas MOSFETs are the voltage control devices. The characteristics or the structure of NMOS enhancement mode transistor would be, it has a moderately doped p-type silicon substrate and it has two heavily doped N+ regions and also a thin insulating material in between, followed by the polycrystalline silicon gate electrode. So these are the points you have to mention when you discuss about the structure of NMOS. So this is the physical structure of NMOS transistor with two N plus doped regions and P substrate, and this is the polysilicon layer, and it is the gate terminal. Here is the source terminal, and this is the drain terminal. Next, coming to the principle of operation, with zero gate bias, that is VGS is equal to 0, the source and drain act as two isolated N region and only leakage current flows in between. Next, when you apply VGS greater than 0, the positive voltage of the gate creates an electric field. So electric field is created here. When electric field is created here, it repels the holes and attracts the electrons, and it allows the current to flow from source and drain when VDS is applied. Next is field induced versus metallurgical junction. So in this, the field induced junction enables voltage controlled operation. This is important. Next, operating regions of NMOS transistor. As we have already seen, there are three different regions of operation in a transistor. One is the cutoff region. Cutoff region has the condition VGS less than VT, and in this the transistor acts as open switch, and no conduction occurs except only for a small leakage current exists when VGS is less than VT. Next is linear or triode region. The condition for linear or triode region is VGS greater than VT and VDS less than VGS minus VT. So this is the IDS in linear region, that is IDS is equal to mu n into Cox into W by L into VGS minus VT into VDS minus VDS whole square divided by 2. So this is the equation. I've already derived this in the previous lecture. You can watch it from the previous lecture. So this is mu n is the electron mobility, Cox is the oxide capacitance, that is the gate oxide capacitance, W is the channel width and L is the channel length. Next, we'll discuss about the saturation region operation. In saturation region, VGS is greater than VT and VDS is greater than VGS minus VT. So in this, the channel becomes pinched off, and the equation for drain current will be mu n into Cox into W by L into VGS minus VT the whole square divided by 2. So when there is pinch off, this is the condition and how it looks. So the pinch off and channel behavior. So at the source end, the full gate voltage is effective, and VT, the channel is pinched off and electrons drift towards the drain due to the electric field. Next is factors affecting drain current. You can easily remember this by just remembering the equation of drain current. So in the drain current equation, we have channel length, channel width, threshold voltage and thickness of the gate insulating oxide layer, and also the carrier mobility along with the dielectric constant, that is mu n into Cox into W by L into VGS minus VT. So all these factors affect the drain current. Next is breakdown and abnormal condition. So the first one is avalanche breakdown and second one is punch through effect. In avalanche breakdown, it's a high voltage that is applied at the drain terminal, and it also impacts the movement of ions. So this causes excessive current flow and also causing possible device failure. Next is punch through effect. Punch through effect occurs when VDS is very high and the depletion region extends from source to drain terminal, and this results in loss of gate control over the drain current. So in summary, you have to write about three different regions, that is cutoff, saturation and linear region, and also write the condition and what is the direction of current flow you have to write. So this is the general summary about it. And coming to the PMOS transistor, it is the complement of NMOS transistor, and The structure is similar, but it has reverse doping polarities. So it has an N-type silicon substrate and two heavily doped P-type regions along with the thin insulating layer and polysilicon layer. So if you remember one, you will be able to write the other one as both are complementary. So operation of PMOS transistor when VGS is 0, as no conduction occurs and source and drain are isolated P regions in an N-type substrate, therefore there is no conduction and current flow. Next is applying a negative voltage, that is VGS less than 0. Applying a negative voltage on the gate repels the electrons and attracts the holes. Next is this is the comparison between PMOS and NMOS transistor. You can just remember this table and write down the explanation. So in NMOS we have P substrate and N plus regions, that is source or drain doping, and electrons are the charge carriers. Also the gate control is based on the positive voltage and the drain voltage is positive for conduction. Also the carrier mobility is very high, and the opposite applies for the PMOS transistor. So further we'll discuss in the next lecture. Like, share and subscribe the channel, and you can also comment about the next lecture, what you want and what are you expecting in the next video. You can comment down below. Thank you.